Show using vector operations that the sum of three vectors formed by the medians of a triangle with each vector directed from a vertex equals 0. Okay, let's try to understand this with the help of a figure first. So here we have a triangle ABC. AD, BE and CF are the three medians of the triangle. Now we need to show that if we take the vector AD, we take the vector BE and then we take the vector CF, find your sum, then the sum must be equals to the vector 0. Meaning to show that, so let's write it down. To show AD vector added to BE vector plus CF vector, they must sum up to give us the 0 vector. Okay, let us begin. So first what we'll do, first we will consider an point O, which is going to be the origin of some coordinate system. Now with respect to this origin, we're going to define the position vector of point A, B and C, including the position vector of the points D, E, F. So let the position vector of the vertex A, B and C be defined by the vectors A, B and C vector respectively. In other words, we can say that OA vector is going to be defined by the vector A. OB vector will be defined by the vector B, and OC vector will be defined by the vector C. Fine. Now, we will find out the position vector of DEF. Now, D, since AD is median on BC, we can say that D divides BC in the ratio 1:1 internally, which means that OD vector will be equals to B vector plus C vector whole divided by 2. Fine. Now, similarly, we can say that B being the median on AC, so E divides AC in the ratio 1:1. So here we can define OE vector as well. So similarly, we can define the position vector of E. The OE vector is going to be defined by A vector added to C vector divided by 2. And then the position vector of the point F is going to be A vector plus B vector whole divided by 2. Now, let's do one thing. Let's first find out the vector AD. How do we find out the vector AD? We're going to use the definition of the position vector. So AD vector is given by OD vector minus OA vector. Now OD vector, that's B vector plus C vector whole divided by 2 minus OA vector, so that's vector A. So this is going to give us B vector plus C vector minus A vector divided by 2. Similarly, we can define the vector BE. So BE vector is going to be OE vector minus OB vector. The OE vector will be A vector plus C vector divided by 2 minus B vector. So that's going to be A vector. This is going to be negative 2A vector. Now we have A vector plus C vector minus 2B vector whole divided by 2. And then finally we have the vector CF. So CF will be OF vector minus OC vector. The OF vector, that's vector B plus vector A divided by 2 minus the vector C. That means we have A vector plus B vector minus 2C vector whole divided by 2. Now what we'll do, we'll add these three vectors. So AD vector added to BE vector plus CF vector, that will be B vector plus C vector minus 2A vector whole divided by 2. Plus we have C vector plus A vector minus 2B vector whole divided by 2. Added to A vector plus B vector minus 2C vector whole divided by 2. So when we sum it up, we'll see that this corresponds to 0. And since on the left hand side we have three vectors added to each other, so on the right hand side we also must have a vector. So that means on the right hand side we are going to get a null vector or a 0 vector. And this is what we needed to show, hence proved.